All right, thanks for coming on back for homework for 7.3.1. The first problem here says that Anthony has added a line of best fit to the scatter plot at the right. Do you agree with where he put the line, and explain? So normally with the line of best fit, we would want to kind of split the point so that they're either touching all of the dots if it's a straight line, or that they kind of split the amount of dots. And we can see that there are a lot more dots on this side of the line than on this side. So actually, I don't really agree with how he placed his line. So I'm going to say, no, I don't agree. The line should be slightly lower, right? And a little bit more to like the left, kind of. And maybe slightly less steep because we can see how many dots there are. Okay. So I don't really agree with Anthony. Sorry, Anthony. All right. For the next one, we have to graph the equation y equals negative 1/2 x plus 6. So in order to do that, and then find its intercepts, we're going to start at the y-intercept, which is 6 on the y-axis. And that's our first point. It is negative, so we know that our graph is going to be sloping downwards. So that tells me I'm going down 1 and then over 2. Remember, rise over run. Down 1 over 2. Down 1 over 2. And we just keep doing that same pattern until we kind of get a few points. And then we bring out the Gorilla Glue packaging. Apparently we haven't thrown this out at our house yet. It's still sitting here. So I'm just going to use it as a straight edge. There we go. Okay. And then for the intercepts, the y-intercept is easy because we already had that one given to us in the rule, right? So the y-intercept would be 0, 6. And then the x-intercept would be right here at, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12, 0. Okay, those are our two intercepts. All right, flipping it on over, we are graphing, oh, good, another line. This one goes to the point 0, 3. So 0 meaning we're not moving left or right at all. We're just moving up 3, 1, 2, 3. That's the y-intercept. And then over 2, 1, 2, and down 1. All right, bringing out our favorite handy-dandy Gorilla packaging. I should be getting paid here from the Gorilla packaging people, Gorilla Glue, since I'm bringing their product into so many of my videos. All right, here we go. So what is the slope of our line? Again, draw a growth triangle. We went over 2 and down 1, 2, 3, 4. So our slope, I'm just going to write it. Can you see it if I write it over to the side? Slope is going to be negative 4 over 2, or when we simplify that, right, negative 2 would be the simplified slope. Okay, that's all it asked for that one. All right, so how many yearbooks should your school order? Well, I don't know. Let's get some information. Your student government surveyed 3 homeroom classes, and 55 of the 90 students said that they would definitely buy a yearbook. Your school has a total of 2,000 students. About how many yearbooks should be ordered? All right, so in order to do this, we need to set up a proportion, right? We know 55 of the 90 students would for sure order a yearbook. So 55 over 90. We have 2,000 total students, so that goes at the bottom, right? Because this was our total number in the class. This is our total number in the whole school. So then we want to know how many of them are going to buy a yearbook, right? So we're essentially going to be multiplying 90 times x, which is 90x, equals, and then on our calculators, 2,000 times 55, which is 110,000, and then dividing by 90, we would get, oops, I definitely did not divide right on my calculator because I got a really big number. Sometimes that happens and you have to be like, oh, yeah, something got messed up there. Okay, and we get, oh, it's going to be like a big number too. I forgot about that. It's a decimal. So we're going to say about 1,222 yearbooks. We're just kind of estimating that because it does go on like 0.22222 for a long time. So that's about how many yearbooks we're going to need. All right, next side, we have to find the area and the perimeter of each of this triangle. Okay, so remember, in order to find the perimeter, that one's probably pretty easy. We just are adding up our sides here. So we're adding 14.3 plus 12 plus 14, right? When we add all of those together, that one's pretty simple. We are getting 40.3 yards. Okay, so there's my perimeter. Then for my area, I'm going to have 1/2 times my base times my height of my triangle. So A equals, I'm going to convert that to a decimal just to make my life a little bit easier. 14.3 times 12. And yeah, 85.8, right, yards. These would be squared, right, because they're area. All right, and then on the last, on the last one, I already set up a coordinate graph, but you can go ahead and do that. We have to graph two different lines and say where they intersect, okay? So the first one is at, the y-intercept is at -3, so I'm going to come down to -3 and plot my first point. Then I know that I'm going down 4, 1, 2, 3, 4, and over 1. I can also grow in the opposite direction by going up 4, 1, 2, 3, 4, and going to the left 1. We just want a couple plot points on our graph here. Okay, and then go ahead and connect. At this point, you probably are finding it very funny that I continue to use the Gorilla Glue. I promise we do have rulers around here somewhere. I don't know. But the Gorilla Glue is right here and it's handy. All right, the next one we have is a y-intercept of +1 right there. And again, the same kind of slope. So 1, 2, 3, 4. Oops, 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. We can go in the other direction too. Oops, 1, 2, 3. I lost my point for a second there. Okay, and then connect these points, and you can kind of already tell perhaps what's happening with their lines. I didn't do a great job of drawing that one, but we did our best. These lines are parallel, right? So where do they intersect? They are parallel. Meaning that they will not intersect. Okay, so hopefully that helps with your graph. That is it for today's homework, so come on back for tomorrow.